Hi everyone, it's Daymi Pelaez, and this is the ABA Exam Academy. This week we're doing section H, measurement. I'm gonna read the disclaimer. First, let me put it on present mode. There we go. All right, so it's nice and big. All right, cool. All right, the ABA Exam Academy was created by and for students to earn their BCBA, BCABA certification. Most of the leaders and participants are not a BCBA or BCABA at this time. These meetings are meant to have active discussions, to collaborate, ask questions, and provide helpful suggestions to better understand the BACB 4th edition task list concepts. Due to this, it is important to know that all viewers and participants are responsible to verify the accuracy of the information being provided in order to successfully prepare for the BCBA, BCABA exam. All right, so some ethical considerations we have is to refrain from sharing any test questions from the actual BCBA, BCABA exam. Refrain from sharing any type of paid resources or any type of specific identifiable client information. If you are going to share any open resources, peer-reviewed articles, or books, please make sure to give proper credit to the author. Finally, we do have a few ABA Exam Academy rules. Because we are in the field of ABA, we need to act in a professional and ethical manner at all times. So number one will be, make sure to mute your microphones if you are not speaking in order to allow us to have a clear conversation. Number two, allow the leader and all participants a turn to speak without interruptions. Number three, make sure to be respectful to others and refrain from using any appropriate language. And number four, have fun. So, we just had a discussion the other day about, I think it's allowing others to speak. So if I need to go over something and I can't finish my presentation, it's totally okay to discuss. I'm okay with talking about or giving another presenter part of my presentation in order to make sure that everyone on here understands all the concepts. So don't be shy. Don't hesitate to ask questions. Just do it, and I'll take all the time I need and listen to all your questions, and we can discuss as much as we need to before we move on to the next topic, okay? Just make sure not to be shy. All right, so because we're gonna move on. All right, so this is the new ABA Exam Academy schedule. We have two new members that are hosts. Jacqueline, she's been doing it for, I think, a couple weeks now. And Emma is starting next week. So as always, we have Daphne Sundays, Lara Monday, she changed to the morning now. Emma is gonna be starting Monday nights. Minerva, as always, Tuesday nights. Me, Wednesday nights. Yanis Bell, Thursday nights. Jacqueline, Friday nights. And Emily is now doing Saturday afternoon. So as you guys can see, we actually have every single day, and we also have 2 on Mondays. So you guys can join as many as you guys want. It's, you guys all know it's totally free. And, the more you participate, the more fluent you get, the more we collaborate, and the more relationships you build. So, all right. So is everyone ready to start some questions?
Let's do it.
All right.
Yep, let's go.
All right. What are the different parts of a graph?
The y-axis.
X-axis. Y-axis.
Phase change line.
Phase change line.
Figure caption.
Repeat that.
Figure caption.
Erica said data points in the chat.
Data points, okay. Give me 1 second, guys. Sorry about that. All right, so I have 2 tips, and we created this on the actual chat room. I think it was like a month ago, but I thought it was a great tip. It was a few of us that we were talking about the x-axis and y-axis and how we can figure out, which one's abscissa and which one's ordinate. Minerva came up with one yesterday, but I remembered this one from the other day, so I wanted to make sure we repeat it. It's PAX, it's like an acronym, and VOI. So I use those 2 to remind myself which one is horizontal. So horizontal is for H, A is for abscissa, and X, horizontal is horizontal axis, and then it's on the X and abscissa, and then the same thing for the other way around, vertical, ordinate, and then Y. All right, so you guys mentioned a few of them, which is horizontal axis, vertical axis, and then we have, someone said data points. There we go, phase change lines, condition change lines, and then the labels. Did anybody say labels?
No.
Okay, so that's one of them. And then someone said data points. Okay, we also have the data path, and then the figure caption, that's part of it as well. Okay, so now we're gonna look at an actual visual, and then we're gonna label all of these on there. Okay, so let's start down here. Which one's this one?
X-axis.
X-axis.
Okay, so that's that one, the HAX. Okay, let's go over here now.
BOI.
Y.
Y. And then, I think this one's the next one. Condition change.
Coordinate.
Mm-hmm.
Okay. And what is this up here?
Label.
That's the label.
Condition label.
Label. And this one, what's this here?
Data path.
Data path.
Data path. And this one?
Data point.
Data points.
Data point. And how about this down here? What's this?
That's a
Figure
figure
caption.
caption.
That's the figure caption.
Figure caption. All right, so you guys got it. Condition labels, data point, data path, and figure caption. There you go. So now we got those actual words, and we put it on a graph. All right, let's move on. All right. So what are the different kinds of graphs used in ABA?
Line graph.
Bar graph.
Bar.
Y graph.
Line graph,
Scatterplot.
Scatterplot,
Standard
okay.
acceleration.
Cumulative record.
Cumulative record.
Vectors, standard acceleration.
Someone in the chat said line and bar.
Okay.
And
There's one I haven't heard yet.
Semi-logarithmic.
There we go. That's the one I'm missing. All right.
Cumulative.
So now we're going to look at visuals, and we're going to label exactly what you guys said. Just tell me what it is.
Mm-hmm.
What's that?
Line
Line
graph.
graph.
Line graph. Good job. All right. What's this one?
Bar
Bar
graph.
graph.
a histogram, guys. It's a
It's
histogram.
a histogram, yes. Andy is right. It's a histogram.
Same thing.
AKA.
Same thing. Good job. Next one. What's that?
Cumulative record.
Cumulative record.
Record.
There you go. Good job. What's that one?
Scatterplot.
No, that's not scatterplot.
That's not
Semi-logarithmic.
Standard
Oh,
acceleration.
yeah.
Standard acceleration.
I'm not acceleration. Minerva's right.
Because I cannot pronounce the other one.
All right, so now that we're talking about standard acceleration, before I move on to the next one, standard acceleration, a lot of people get either they get it confused or they get it wrong. So I want to go over a few things about it. So standard acceleration is on Cooper page 139 to 140. Who and when was a standard acceleration chart created? Who created it?
Ogden Lindsley.
Lindsley.
Ogden Lizzie. And when?
I don't know, it was 1951
Some
or
time ago.
Long time ago.
Long time ago.
Did you say, Martin, 1951?
I just on top of my head, I think that's what I remember.
You're pretty
Wow.
close. It's
1959?
1960.
60, okay.
Wow.
All right. Next question is, yeah.
Mhm.
What type of chart is it and how many types are there?
I
The
think there's,
semi-logarithmic chart, right?
It is a type of semi-logarithmic chart, and how many are there? What type? How many of the standard acceleration are there?
How many types?
Yeah.
One.
How many?
is it ascending, descending?
No.
You mean the AKA?
No, there's actually 4 types of actual like data sheets.
Oh, really?
Yeah.
Wow. Oh, we're gonna learn.
Yeah.
Learn
What's the
today.
difference and what are their uses?
You're on the right track. Okay, so I'm gonna give it to you. It's semi-logarithmic chart, and there are 4 types. There's a daily, a weekly, a monthly, and a yearly.
Oh, okay.
Yeah.
And they look very different. So there are 4 different types. If you were to purchase the data sheets from them, they would ask you, what type do you want? And then you would choose which one of those 4.
Okay.
Okay. I think that the more I think I read on Cooper that the more popular one is the daily, but that daily and yearly is used most.
Mhm.
So they use them together, daily and yearly, so that you can see progression over time with yearly if you're working with a client for a long period of time. And then daily is just to track daily data. Okay. All right, the last question for standard acceleration is, this chart is a display of what type of data? So Martin said this before. Can you remember what you said, Martin?
I think I talked about ascending, descending.
Mm-hmm. So it displays ascending and descending data of what type of data?
It's for precision teaching, right?
Precision teaching is the type of method that's used to teach. You use the standard acceleration as a data sheet that uses standard acceleration. They work together, standard acceleration and precision teaching, but you can use standard acceleration for any type of data, for any type of problem behavior. You can use it to teach fluency, like precision teaching, but you can also use it for problem behavior. You can use it for both. But it ascends and descends, but what does it look at?
For the rate?
You mean by going by multiples? Is that what you mean?
It goes by multiples.
But it's for the rate? To display
Rate.
the rate?
That's what I'm looking for. It looks at rate.
Nice job, Minerva.
There you go. So it's a combination of everything you guys said. So it is a display of acceleration, a linear measure of frequency change across time, multiples like Nadia said, and it describes deceleration and acceleration like Martin said. So the 3 of you were perfect. All right.
We should go to the exam together.
Yep.
So, one thing.
The 3 of you got 1 question good. That's awesome.
Oh no, what happened?
Somebody's heart is beating so fast today.
Yeah, I was gonna say, there's one microphone that is acting up.
That microphone is attached to somebody's heart.
Mm-hmm.
1 second, guys. I have no idea what happened.
While we wait, you guys want to review the AKAs for line graph? Line graph?
Hi, Daymi.
Hi.
There is a new person who joined, but I don't think her name is Stephanie.
Hi, Stephanie. How are you?
Hi.
Hi.
Hello.
All right, cool.
For
So,
having me.
I'm sorry?
I say thanks for having me.
Welcome.
Welcome. All right, so where were we? We were here on present. All right, so let's try this again. So we were on the last question. All right. So what I was trying to say was it multiplies, it goes by multiples, but it also goes by, it divides. So it's not, so you got to think about it just like the equal interval is add and subtract. That's why it's called add subtract. This one is multiply, but it also divides. It does the opposite. Okay? So when we accelerate, we're gonna multiply. We're gonna go up in multiples. And when we decelerate, we're gonna divide. So we're going down in multiples because it's the opposite of multiplying is dividing. Okay?
Got it.
All right, awesome. I wanted to make sure you guys know that because a lot of people, when they think about standard acceleration, they're completely lost. So this is little information that will get you guys to understand a little bit about it. Just in case, I mean, I really doubt you guys are going to get all this stuff on the test, but just so you know what you're getting into.
And since you've done it, have you ever done one that decelerates?
Yeah, so the X's usually decelerate.
Okay.
The dots accelerate. So usually you want them to go opposite.
Got it.
Yeah. So if you're teaching fluency of reading, you want them to have more correct responses than incorrect responses.
So basically, in one chart, you're gonna have both things happening.
Right.
Acceleration and deceleration. The X are gonna be this in doing deceleration, and the data points are going to be.
So I've had clients before that I've taught them like identifying letters, letter identification. And then I'll give them 20, like a list of 26 letters. And then all I do is track the amount they get right. Okay. So let's say in 15 seconds, they get 20 out of 26, right? So I go up on the chart 20, and then I go down 6 because they got 6 wrong out of the 26. You get me? So there would be, on the X, which is wrong, it would go down 6, and then it would go up 20. It's confusing if I don't show you it on an actual graph, but if the dots are correct, the X's are incorrect, and then usually the X's start high, but they're going down, decelerating, and then the dots go up, accelerating.
It makes more sense now. It does.
Can I ask you what symbol you use for the correct and which one for the incorrect?
Correct is dots. They're regular data points. And then incorrect is X. Okay. It's just a regular little, tiny little X.
Okay, thanks.
Yeah, no problem. All right.
Can't you tell the patterns, like, you know, the X pattern and like the dots pattern?
So the chart has numbers on the sides, and you just keep taking data on them, and then you can also get like a trend with standard acceleration. Mm-hmm. So you'll see a pattern once you do the trend line.
Okay.
Yeah. All right. What type of graph is this? The one on the right. I'm sorry.
Cumulative record?
That's cumulative record.
It seems like cumulative record, but
why wouldn't it be line graph?
It's a line graph.
All right, so look at the difference between the one on the left and the one on the right. Okay. They're both response rate of responses. Okay.
But one is equal 10, 20, 30, 40, 50, 60. The other one is it's go by 2.
Mm-hmm. Yeah.
And it multiplies.
Okay, that was very good. You noticed something about it. And so I'm gonna, because I'm still learning this, so I'm just gonna give you guys the answer because it's basically the same information, just that one is one type and the other one is another type, okay? So the first one is semi-logarithmic chart, okay? The one on the right that has the arrow pointing down is semi-logarithmic chart, okay? And then the one on the left is equal interval chart, okay? And then this information is on Cooper, okay? I wrote a comment on this specific graph, okay? Here's the information on the bottom that's on the actual page. This is logarithmic y-axis and then equal interval, equal distance y-axis, okay? The information I found about it says the behavior change appears as an exponential curve on the arithmetic chart is in straight line when plotted on the semi-log chart, okay? So notice that the same information is curved because we're working on both axes at the same time. And then on the semi-logarithmic chart, they're only working on one axis proportionally, okay? So it's always gonna be straight on a semi-logarithmic chart, and on an equal interval chart, it could be curved. Most of the time on an equal interval chart, it's gonna be curved. This is why we use line graphs, so we can see exactly the pattern. We do the trend line to see the average, but usually our graphs in ABA are curved. I wanted you guys to see the difference between both, equal interval and
So
semi-logarithmic.
we use equal interval mostly, right?
Mostly, yes. That's what we use most of the time. Okay, so equal interval is what we use most of the time. It's on the left, and semi-logarithmic is on the right. But it almost seems like when you look at it that that's a trend line, right? So if we were to move that line over to the left one, it would almost seem like the trend of the equal interval chart. And the reason that's happening is because on one, which is the left one, they're taking the data on both the y and the x axis, where on the right one, semi-logarithmic, they're only looking at one axis at a time. So in this one, they're only looking at the y. Sometimes they can look at the x, but it's only one at a time. They can't do both. Does anybody have questions about that? This is on page 139 on Cooper. You want to move on, or you guys have questions?
I have a question that might be a silly question,
No, go
but I'm
ahead.
gonna ask anyways. So when we're saying, like what you wrote there, a semi-logarithmic chart is only one axis, and so what do you mean by only one axis? Because they have to, it's the y-axis, right?
Right. Mm-hmm.
But then in the x-axis, there's a data point in the next dash or the next line there, right?
So that's why, right, but that's why the left one curves, because it's taking both the information from the y and the x. You get me? So do you see that it starts off 0, and whatever the first line is, it starts very low. And then it curves up slowly. Where the other one is 2, 4, 8, 16, 32, 64. You get me? It's exactly right. And that's what standard acceleration does. It multiplies.
That part I get. The part that confused me was the part that said that only one axis.
Right. So this one is only doing the y-axis. They're not looking at what's on the bottom. They're not looking at anything on the x-axis at all.
So on the right
Doesn't
side,
curve.
only y, those dots are representing only y-axis, no x-axis.
The semi-logarithmic is only representing the y-axis. Yes.
Okay.
Where equal interval charts look at both at the same time.
Okay, thank you.
Yep, no problem. All right, what type of graph is this?
Scatterplot.
Scatterplot.
A scatterplot.
Scatterplot.
All right, awesome. You guys got it. Scatterplot. All right, we're gonna do a little break. Who likes Big Bang Theory?
Hey, want to go back to the scatter plot?
Go back?
Yeah,
Hold
because
on.
I remember I had this question on the exam. It asked if it was a positive, a negative, or no correlation scatter plot or something along the line. I remember I had this question on the exam a while back.
I think if it's no correlation, you see how all those dots are like kind of scattered all over the place? I believe
Yeah.
I think that's what it means when it says no correlation, but I it's been a while since I've studied that part.
Yeah, but I know, just make sure you know how a positive one looked like and a negative one looked like and a no correlation looked like. Because I remember I had that question on the exam. Just know the difference.
That's good to know. Thanks for sharing that.
Yeah.
Awesome. All right, well, let's move on. All right, quickly. I think it's like 2 minutes. Make you guys laugh a little.
Some psychologists perform operant conditioning with punishment. Maybe we can come up with a punishment for straying off topic. Getting to see who wins at pigeon ping pong comes to mind. We could snap a rubber band on our wrists every time we get sidetracked. Not bad. You know, in medieval times, idle chatter was punished with a device called the scold's bridle. It's an iron cage just locked around the head and pierces the tongue. If only we had one. Oh, I'll check it out. Okay, so we agree. Whenever someone takes us off topic, they get their arm hair yanked off. When you go into the because my eyebrows will think I've been cheating on them. Now, one benefit of quantum coupling.
Boy, no question. Who decides if someone's gone off topic?
I think it'll be pretty clear. If not, we'll take a vote. Also,
We didn't vote.
We didn't have to. That was clearly a tangent. Now, come on, back to work. If we're leaning towards quantum coupling,
You said quantum coupling. That made me think of the show Quantum Leap. That's a tangent, and it's your fault. No, I vote that is not a tangent.
Thank you. And now I'll you.
That was your fault. Yeah. That is a lot of hair.
Everyone stop. This was a stupid idea. Negative reinforcement isn't working.
You mean positive punishment. Negative reinforcement is the removal of a positive stimulus. It's a common mistake.
Reinforcement is really wrong?
Well, it's used incorrectly all the time. Even Bill Murray makes that mistake in the first scene of Ghostbusters.
No way. Not Bill Murray. I'm studying the effect of negative reinforcement on ESP. Bill Murray did get it wrong.
Jump ahead of the Stay Puft Marshmallow Man.
No!
Leonard's right. We can't just jump ahead. We have to watch the whole movie.
All right, guys. Little break.
They're hilarious.
All right, so I have like 8 minutes, but I'm gonna do a couple more. It says, can you identify level, trend, and variability? All right, so
Of course.
what is that?
Level.
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 And then I'm gonna ask you what type of level. So let's start from left to right. What's on the far left?
High.
High.
5, the middle?
Middle.
Moderate.
Okay. And the next one?
Low.
Low.
Low. Okay, so we have high level, moderate level, and low level. Good job. All right, what is this?
Trend.
Trend.
Trend. Okay, and what type from left to right?
Ascending, descending, and
No trend.
Decreasing and stable.
So we have, I heard ascending, descending, and 0. I heard no trend. I heard stable.
Flat.
Flat. That's a lot of, we have a lot of words here. Great job, guys. All right, what's another? I heard ascending and descending for these two. Do we have any more for these terms?
Increasing.
Increasing and decreasing.
Good job. All right, so increasing, decreasing, no trend, and then you guys said all the other ones. Nice job. All right, how about here? What do we have?
variability.
Variability.
Variability. All right, from left to right, what's this one? What type?
Low variable.
Variability.
Low?
Yeah, low.
Variable. So this is a regular variable level of responding. Regular.
Yeah.
So it's still not very variable, but it's not low, okay?
Yeah.
Okay, what's the next one up here?
No
variability.
Variability.
That one's definitely low. So stable level of responding or low level of responding, okay? How about this one over here on the right bottom?
Highly variable.
High variability.
Highly variable, and on Cooper, they mentioned a different name for highly variable. Does anybody know it?
Very variable.
The word is extreme. Extreme variability. Right? All right, on here, I want you to compare your baseline to your intervention. So first, let's look at A and B on the top left corner. Look at your baseline and look at your intervention, and then the same goes for B, baseline and intervention. What would you say about the level and trend? Just A and B.
First one is same, right?
No variability.
No variability.
No, we're not looking at variability.
Trend.
Let's level and
Trend.
Moderate level.
The first one has
Same
level.
level. Nothing changed.
Stable
Okay,
trend.
So I heard someone say nothing, no change. I heard someone say moderate level. What else?
So no trend and moderate level, right?
0 trend.
Or 0 trend.
All right, let's see. A and B, we're just looking at A and B. So A and B is no change in level and trend. So there's no change in any of the two.
Oh, okay.
Okay, so that one specifically, you're looking at the baseline, you're looking at the intervention, and on both A and B, there's no change in either level or trend. Okay, so now let's look at C and D.
Wouldn't the level be different in B?
So the level?
The intervention's
There's
higher than the
change in level.
baseline.
Changing level, no changing trend.
Increasing level.
Or
Someone was asking about B, right?
Mm-hmm.
Why is there no trend here?
The level in B for the intervention would be higher than baseline.
On Cooper, that's what it says. So I was thinking the same thing you were thinking, but that's what it says on Cooper. It doesn't have an explanation. It just says that on B, there's no change in level and trend. So I have the page number one.
Because in both the trend it's increasing, right?
It's staying the same.
So
It has the same
baseline is
direction.
increasing the trend, and the intervention is also increasing.
Right. So no change.
So there's no change.
Not in the trend, but in the level.
Oh,
Oh no, I thought we were talking about A and B. B.
Yeah, we're looking at B. We're looking at B.
Yeah, no change.
I can look into it again, but I know that I got this exactly the way it was in the book.
So he said he had both no change in level and trend? Is that what you?
Yep, no change in level and trend.
Right.
Do you know what page it's on?
Because both trends, like she said, both trends are increasing, so it doesn't change from the from the baseline to the treatment.
All right, guys, I have less than 1 minute, so let's get out of this and just go into the same link, okay? Ah.